Okay, so this is the last set of slides, last lecture for Unit 3, Cardiorespiratory System. So we're at our final respiratory challenge, number 4. All right, same objectives. This time we've got increased ventilation, which leads to an increased work of breathing. Okay, so sometimes I don't think we think about this, but if you breathe more, that's going to require more oxygen to your diaphragm and to your internal or your inspiratory and expiratory muscles. Okay, So when I'm exercising, to breathe more costs more oxygen. And so this can lead to something called respiratory steal. During max exercise or near max exercise, your respiratory muscles might actually use 15% of the total oxygen that's consumed during exercise. This is great, or it's great that we're able to do this. The problem is if oxygen or if blood flow, that's probably a better way to look at it. If blood flow is going to the lungs, it's not going to your legs or wherever you're using muscle for your exercise. Therefore, there's not going to be as much oxygen available. Therefore, this could ultimately lead to you fatiguing more quickly. Okay, so there's a trade-off. I want to exercise harder, but that requires my lungs to work harder. And really, it's not the lungs, but the respiratory muscles, but as a result, I won't be able to work as hard because I'm taking away some of the oxygen that would otherwise go to my legs or whatever. Okay, so if I decrease the work of breathing, I'm going to increase blood flow to my legs. If I increase work of breathing, I'm going to decrease blood flow to my legs. All right, and so what we're seeing here is the relationship between how much blood flow is going to your legs and how much what the cost of work of breathing is. Okay, and so here at this 100%, what we've got, this is normal. Okay, and so when we breathe less, more blood flow can go to my legs. When I breathe more, less blood flow can go to my legs. So there's a cost, right? And so just to show, we can go from 5 to 7 liters at rest up to 110, which isn't crazy high. I've seen somebody breathe 200 liters a minute during max exercise. This was a cyclist, a very trained cyclist, a little bit bigger than me, probably 6'4", 6'5", so a big guy. All right. And so what happens is not only do we breathe more frequently, which would be the number of cycles here that you see kind of on the x-axis, but our breaths also get bigger as well. Okay. But the problem is when we take bigger breaths, we get to a point where the work required to fill up or empty our lungs is increased. Okay, so we've got pressure, and think of pressure as just how much work is required to increase our volume. When we're on this flat part of this curve, or flat's the wrong word, but kind of this straight part, middle part, okay, right here, we get a lot of bang for our buck. We increase pressure, and we get a lot of volume. But once we start getting above, kind of 75, 80% of total lung capacity, or below about 35% total lung capacity, it requires more pressure to either increase or decrease lung volume. Okay, there's a reason that we don't breathe at total lung capacity. And if you don't believe me, just fill your lungs all the way up. Okay, and then try and breathe with your lung capacity at a very high lung capacity. It's hard, it's difficult, it's uncomfortable, and part of the reason is you have to generate a lot of pressure to get air in. Not so much to get air out at the total lung, but then the same is true if you tried to breathe all the air out and then breathe normally. It takes a lot of effort to get that air out when you're at a low lung capacity. Okay, and so what we've got here is something called a flow volume loop, and I wish we had the equipment, working equipment that we could show you how this works, but basically what we do is we just have somebody breathe. And notice that we've got volume on the x-axis and airflow on the y-axis. Now, it's a little bit weird that as we increase volume, we actually go, so this is high volume, this is low volume. Okay, and as we breathe out, so expiration goes up, inspiration goes down. Okay, so what we've got here on the outside is what we call we've done a forced vital capacity maneuver. So remember, vital capacity is the maximum amount of air that you can get in and out of your lungs. So we have people empty out their lungs, and then they take a big breath in as fast as they can, and then they blast it out as hard as they can. And you get this pretty typical curve in a healthy individual. Okay, and then we've got these circles in inside this maximum effort. Okay. And so this is tidal volume, and then this is tidal volume getting bigger. And so just think, with every one of these loops, we're increasing exercise intensity. All right. Now, eventually we're going to get to a point where, to get air out, we're going to be up against this maximum curve. Okay. And that's when we become what's called flow limited. Like, we can't get out any more air because it requires maximum effort to get it out. Okay. And so we have to generate as much pressure as possible. And so we get to a point where we can't get any more air out. Okay. And so no matter what we want, we're kind of stuck there. And so we become what's called flow limited. Now, depending on how healthy you are, that'll occur earlier or later. So if you're healthy, you're going to stay away from this maximum line, and you're going to be all right. But once we start approaching max exercise, or being able to meet the capabilities of our lungs, we'll become flow limited, and it will be difficult to get air in, and we're working our lungs as hard as they can, and it's not necessarily enough. Okay? And so with that, we will end.